Hey guys, welcome to my channel, and today is day 3 of solving POTD series, and today's problem is split an array into two equal sum subarrays. So let's solve it. The question says given an array of integers ARR, return true if it is possible to split it into two subarrays such that sum of two subarrays are equal. If it is not possible, then return false. So let's observe these two examples and let's find out the basic approach of this question. So the example says array 1, 2, 3, 4, 5, 5, and if let's see if we are able to divide this into two subarrays such that their sums are equal. So this array, from this example, we can easily say that we can divide this array into two subarrays as 1, 2, 3 and 4, and as one subarray, and 5, 5 as second subarray. Their sums are 10 and 10, so we can return true that these arrays can be divided into two subarrays. Let's see second example, 4, 3, 2, 1, and let's try to divide this into subarrays and check if their sums are equal or not. So 4 and 3, 2, 1, their sums are not equal, so not this subarray. 4 and 3 and 2 and 1, so their sums are not equal. 4, 3, 2 and 1, so their sums are not equal. So therefore we can say that this array cannot be divided into subarrays whose sums are equal, so we return false. So the basic approach of this solution can be to iterate through this array and then just divide two subarrays as we discussed earlier from 0 to that particular index and then I to remaining subarray. And for each and every index we divide two subarrays and we calculate sum respectively, and parallelly we check those sums and compare those two sums. If both sums are equal, we return true. If both sums are not equal, at the end of the function we return false. So the first approach would be to iterate through this array, and we divide this array at each index into two subarrays from 0 to I and from I to n minus 1. We calculate those two sums and store it in a variable s1 and s2, and after each sums calculations we compare these two sums. If both are equal, then we return true and we get out of the function, and if we didn't find at the end of the array, then we return false at the end of the function. So let's code this approach. So initially we take the size of the array as n and we iterate through the array using for loop. We take two sums. Now we divide those two subarrays at each index I. So one would be from 0 to I. We calculate that sum, and another would be from I to n minus 1. We calculate these two subarrays sum. After calculating those two subarray sum, we compare those two sums. If both are equal, we return true. If not, we return false. Now let's check. Let's submit. So we are getting time limit exceeded. So this approach is fine, but it's taking too much time. So the time complexity of this approach would be O of n square, as we are iterating through this array two times. So this for loop takes O of n time and the inner loop takes O of n time. So the total time complexity would be O of n square. Space complexity would be O of 1, as we are not using any extra space. So the optimized approach would be this, as we calculate the total sum of the array at once initially, and we iterate another loop from index 0, and we run through all the way to the n, and we calculate the current sum. At each index we check this condition as 2 times of current sum is equal to total sum or not. So this condition indicates that there's a subarray at index I whose sum is equal to the next subarray from I to n minus 1. So this condition should satisfy to return true, or else we return false at the end of the array. So let's code this approach. We initially take the total sum. We calculate the sum of an array. Now we take current sum. We iterate through the array and calculate the sum of the array at that particular index. We check the condition if 2 times of this current sum is equal to total sum or not. If it satisfies this condition, we can return true, or else at the end we can return false. So that let's compile and run. Let's submit. As you can see, this approach is successfully submitted. So the time complexity of this would be O of n, as this for loop takes O of n time and this for loop takes O of n time. And space complexity would be same, which is O of 1, as we are not using any external space, vector or stack.